Okay, welcome back everybody. We're going to do a couple more plots with matplotlib. We're going to get things that are a little bit more fancy this time. We've already built plots like this one where the plots are layered on top of each other and we got legends and labels and titles and all that stuff. Most of your plots are going to be this way. But let's say that you've got a plot that you want to build that's actually really predictable and we can do it inside of a loop. So say I want to plot x squared, x cubed, x to the fourth, x to the fifth, all on the same axes. Okay, well, these are all really the same type of function. It seems like this is a very predictable pattern. So a loop is really a good idea. So in my plotting code, of course, I'm going to import numpy and matplotlib.pyplot with their standard nicknames. And now for every plot, you start by creating a domain. So I'm going to comment that. Now in this particular one, I didn't tell you the domain, so let's just say the domain is from 0 to 1. And I'm going to do that with a linspace this time. Linspace is, it will return an evenly spaced number of, evenly spaced numbers over a specified interval. So say I want 0, 1, 100, that will do 100 numbers from 0 to 1. And it'll end at exactly 1. So that's my domain. And now what I'm going to do is I'm going to loop through all of the types of functions. So I'm going to say for n in range 1, 5. So let's see, 1, 5 would be 1, 2, 3, 4, colon, y is equal to x to the n. And then I'm going to plt.plot x against y. Now let's stop and think about what this loop does. I've got my domain, and then I enter the loop for n in this thing. Now range 1, 2, 3, 4, 5, range 1 through 5 is 1, 2, 3, 4. So the first time n is 1. This says take all of my x's to the first power. Store that as y. Then plot the ordered pairs x, y, and connect them with a straight line. Next time through the loop, n is 2. Then I'm going to take everything, square it, save it in y, and plot it. And so on. If I back out of the indentation and do plt.show, we'll check that out. I've got x to the first, to the second, to the third, to the fourth. Let's put a grid in there just so I can see things a little bit nicer. And let's maybe do more of them. Cool, so I've got x to the first, to the second, to the third, to the fourth, to the fifth, sixth, seventh, so on. So there's a really quick way to build a whole bunch of plots on top of each other. And we're just leveraging the fact that every time you call this, before you call plt.show, it just layers that stuff right on top of the plot. Now, I want to add something a little bit more fancy to this. It'd be nice to have a legend. And then we're going to add labels and all that stuff. So my legend entries, I'm going to start off as a blank list. Okay, and I'm going to show you why here in a second. Inside the loop, I'm going to append to that list the new legend entry. So I'm going to call this x to the power of plus str string n. Now go with me for a second here, plt.legend of my legend entries. Now let's parse this code. For n equals 1, I build the x, or I build the y's, I plot the x's against the y's, and now I add to the list of legend entries this text, x to the power of. Now I'm going to add to that text a string, which is more text, of 1. And then I'm going to do x to the power of 2, x to the power of 3. And now I get a nice little legend, and it actually shows me the colors there. And if I do like 10 of them, or 1 through 9, it starts to overlap your plots. And it'll try and move the legend over so it's in kind of the least obtrusive place. That's not always possible, but it does a pretty darn good job. So I'm going to leave it to you to write the X label command, the Y label command, and actually get meaningful X and Y labels and titles on this thing. I'm going to leave that to you. I'm not going to do that code right now. So go ahead and do it. Put me on pause. Go ahead. Okay, we're off pause. Let's go do something that's also kind of interesting. Let's say you wanted to plot a sequence. Okay, so we're going to plot the terms in the sequence xn plus 1 is equal to minus a half xn plus 1, starting at x naught equals 3. So this is just a sequence of numbers at points, so they should not be connected. A sequence is discrete points, not continuous points. So since I'm going to do plotting, I'm going to import all of the common tools. NumPy, because I'm doing math, on numerical math, and the pyplot because I'm going to be plotting. And I'm starting this sequence at 3. So I'm going to say x equals 3. Now, there are a couple ways you could do this, but the simplest way I could possibly think of is let's just build the thing in a loop. I'm going to plot, plt.plot, 0 versus 0, comma 3. So that's the ordered pair 0, 3 as a blue circle. So that's the letter O for a circle. Okay? So that's the starting point. Then I'm going to go into a loop and say for n in range 1, comma, whatever. Let's say we're going to do the next 20 terms. Excuse me. Now I'm going to say x is, I'm going to apply the sequence rule, negative 0.5 times x plus 1. And I'm going to plot n against x as a blue circle. I'm going to back out of my loop, plt.grid, so I've got a nice little grid on it, and plt.show. So before we run it, let's parse the code again. This is my initial condition. I plotted my initial condition at n equals 1, or n equals 0. And then I just built the sequence inside of a loop and plot each term in the sequence. Let's see what it does. Bingo, there we are. Beautiful. Okay, that's great. plt.xlabel. This thing is n, that's my sequence number. plt.ylabel. This thing is x sub n. And I should probably put a title on there too. Sub equals negative 0.5 x sub n plus 1. Okay, we got a nice title. We have the subscripts and whatnot. You can make those look a little bit nicer. That's for a different video at a different time. All right, so we've got a nice little fancy looking plot here of a sequence, and it's wonderful. It actually shows what the equilibrium is over this sequence pretty good. It's a little over 0.5, maybe about 2/3. And I'll leave that for you to actually verify. So see me in the next video for some more plotting.